Thank you everyone for joining. And today I want to cover the front-end system design. How we will be doing is going through a problem statement more, because I think that is better. I can explain things to you, because when I was preparing for interviews, I could get literally no content on the YouTube. This is everything is what I would tackle in the interviews.
So hello and welcome everyone. Hope you're keeping well and staying safe. This is Subsanjum and I am working as a community executive at TechRo. Swiggy, Udan, Dunzo, etc. I guess we micro. I'm still
going through a problem statement more, because I think that this is better. I can explain things to you, because when I was preparing for interviews, I could get literally no content on the YouTube. So I want to help everyone, and this is everything is what I would tackle in the interviews. You might have a different approach, so don't take it as like this is the only solution. Because in system design, we don't have any right or wrong answer, but there are too many wrong answers. People say there are no wrong answers, but there are very wrong answers as well sometimes. But yeah, so just follow the pattern, those things that you should talk about, and you can always go with your own solution. So I'll just start sharing my screen, and we can, without wasting any time, let's start. So first we will have a general introduction, then we will be talking about how to approach a system design question with the help of an example. And we will also cover some of the follow-up questions which are often asked by the interviewers. Okay, so in front-end system design, usually we have two types of questions. So one is the product design, which we also call high-level design. So this will be mostly around bigger problems. For instance, build a product like YouTube, build next Netflix, Facebook, WhatsApp. So these are very broad level questions. But then we also have a low-level design, component design, and mostly till 5 years of experience, you are expected to have a low-level design. So this will be focused on a particular feature, like build a search bar of Netflix, stepper component, infinite scrolling feed, Pinterest layout, so all those things. And what happens during the high level design also, many times interviewers will ask you to focus on LLD of a certain part. So this is also very important to know the component design. Today, we will be covering more on the LLD side. So product design, we can cover sometimes else, some other time, because it can take more time. It's more high level. So we are going to take this example, autocomplete. So this is a very famous question which was asked in a lot of good companies, Flipkart, Swiggy, many, and even I was asked this question in one of the FANG interviews. So if you are preparing for FANG, it can be useful to you. So first step is usually you start with clarifying the question. And this is very important, because this is also considered negative if you don't clarify the question, that what the question is. You are mostly getting an abstract statement. Like in this question, interviewer will be like, okay, design a type ahead. Now you should ask, okay, if you have the same understanding as the interviewer, that you want to build something which on typing should give you results, what is the goal of this feature? Whom you are building it for? Do you want a generic component? So clarify all the questions in 1 minute. Ask them that what is this feature? And if it is like autocomplete, then you should consider that, should you consider some typing errors or not? Like in this question, all these are the valid questions you can ask about. Then you can take on the general plan we will be following during the interview is these 6 steps. So first we will go about the requirements, functional and non-functional requirements. You can also club them up in a single requirement, doesn't matter. And then third thing is that component architecture. This is very important. So you design, if you're doing a component design, then you should do a component architecture, discuss the props and events, then discuss about the performance and accessibility. So don't miss even performance and accessibility. It's also marked that person did not talk about accessibility and performance. So first we'll cover the functional requirements. So like we are designing a type ahead, what all functional requirements we can have. The basic requirement somebody can have is like when you type on the input, you should get some results. So this is the main functional requirement. Then you should have like a debouncing when you type, because you don't want to overload your network with a lot of calls. So you want to have debouncing. You also want everything to be customizable. So when we are building something, think that you are building a generic thing so that everyone else can use it. We're not building it for a specific case, right? So you want your search results to be configurable, maybe your input box also to be configurable, and you should support static data and the data coming from an API. So this part you can also ask from the interviewer, that should we support the static data? Where does the data live? Is it on client? Is it on server? So you can ask about that, but basically we'll be covering all these 4 things.
I'm pretty sure you must be thinking that do we really need to learn about how to design URL shortener? At interview, if the interviewer asks the question, I can easily design, right? Because all we need is an app server, a database. When the user gives the long URL, convert it into short URL and update in the DB. When the user hits the short URL, you're gonna look up for that short URL and get the long URL and redirect to that particular URL. I'm pretty sure you must be thinking that do we really need to learn about how to design URL shortener? At interview, if the interviewer asks the question, I can easily design, right? Because all we need is an app server, a database. When the user gives the long URL, convert it into short URL and update in the DB. When the user hits the short URL, you're gonna look up for that short URL and get the long URL and redirect to that particular URL. It's that simple, right? But I'm sure this won't work at scale. My name is Naren, and in this session, let's talk about how to do system design for URL shortener. And also learn about all the different kind of problems which you're going to face on the way, and also different strategies and solutions to overcome these problems. Here's the tip for system design interview questions. Before making assumption about the system, please talk to your interviewer and clarify about the assumption you're making. For this particular topic, URL shortener, the questions could be like, what is the length of the URL which is shortened? The second one is, what is the traffic, or what is the volume of the traffic? The third question could be like, is the system single instance or should we scale it? Let's make some assumptions about traffic and the length of the shortened URL. For comparison, or to get the number of users in our system, let's make some assumption. Say Twitter has about 300 million active users per month. If we are 10% popular than Twitter, that means that we might get 30 million users a month. That equates to 1 million users a day. Think about all the reads and writes which these 1 million users make in our system. Okay. Now let's make some assumptions on URL length, that is shortened URL length. Say for example, if our domain is usurlshortener.com, so we have to have a unique code which maps to the long URL, right? So let's keep the length of the unit code to 7 characters, okay? With these two assumptions, let's go ahead and design the system. Before doing system design, we also need to understand how much data we might insert into the system. To do that, we have to do something called as data capacity model, in which we have to, before doing system design, we also need to understand how much data we might insert into the system. To do that, we have to do something called as data capacity model, in which we have to do some assumptions on what kind of data we're going to save in our database or any other storage, and then calculate for 1 year how much data we might store, for 5 years how much data we might store. To do that, what we need to do is think about all the different kind of attributes we're going to save in the database, or you can think of columns, right? So definitely for this URL shortener system, we need to say long URL, short URL, created at time, and expiration attributes we're going to save in the database, or you can do 1 year how much data we have in model, in which we have to do some assumptions on what kind of data we're going to save in our database or any other storage, and then calculate for 1 year how much data we might store, for 5 years how much data we might store. To do that, what we need to do is think about all the different kind of attributes we're going to save in the database, or you can think of columns, right? So definitely for this URL shortener system, we need to say long URL, short URL, created at time, and expiration at time. So for that, the maximum URL characters allowed is almost like 2048 characters. That leads up to about 2 KB in size. The short URL, it is 7 bytes or 17 character. That is www.url shortener, that is us.com/7 character. That means that it will be 17 characters, and then it leads up to 17 bytes. And the created at, we will save epoch time, that will lead up to 7 bytes, that is 7 characters, and same expiration at will be 7 bytes. Total, it will give us to about 2.031 KB of data per entry, or per shortened URLs entry in the database table. So using this number, let's calculate for 30 million users per month, how much data we might generate. For 30 million users, we will generate about 60.7 GB data per month, which leads to 0.7 terabytes of data per year, and it also leads to 3.6 terabyte in 5 years. Now, think about how much reads and write we might do onto this much data in the database, because that's how we can understand whether we should go for RDBMS or NoSQL, or how the data modeling should be. So let's talk about the URL shortening logic. The core for the URL shortening logic is generating this part of the shortened URL. This is the shortened URL domain, and this is the shortened URL unique ID, which is used to locate the long URL and redirect it. So this particular part, let's think that we take 7 character ID here. So let's talk about how we generate this unique 7 character ID. There are 2 algorithms which you can use. One is base62 and one more is MD5 hash. Base62 takes decimal number or integer input, integer or long, and it gives out the base62 output, which contains capital letters, alphabetical letters, small letter alphabetical letters, and also the numbers. In MD5 also we get base62 output, but the input given to MD5 hash will be mostly different unique string. In our case, the unique string is, we can take the long URL which we're supposed to shorten. We can give the input to MD5 hash itself, and we get the base62 output. But the problem is MD5 hash gives you a really lengthy output, which is more than 7 character. Ideally, it will be like about 20 to 25 character output, right? So we have to take only the first 7 character in the MD5 output and then use it as the unique ID for our shortened URL. The problem is, in this case, there is a lot of collision. For 2 or many different long URL input to the MD5 hash, we might end up getting the same unique ID for our shortened URL. And that could cause data corruption in our database. We have to do a precautionary check whether the 7-character ID which we got from the MD5 hash are already present in the DB or not. If the entry is already present in the DB, if the long URL which we use to generate the MD5 hash is not same, that means that we can't update the entry in the DB because it could cause data corruption. And that's why the safest bet is to use base 62. Now you can ask one more question. Why always base 62? Why can't we use just the base 10? So the answer to that is, if we use the base 10, then the unique ID looks something like this, say 14372. So the unique ID after the short URL domain looks something like this. If you use base 64, it looks something like this. So in base 62. In base 62, the combination of characters which we get is, say, from A to Z capital letter, that is 26 characters, small letter A to Z, that is 26 characters, and 0 to 9, that is 10 characters, totals up to 62 characters. Using 62 different characters, we can generate 7 character unique ID. If you use base 10, we can only we can generate 7 character unique ID also. But the problem is, with base 10, we can get up to 10 to the power of 7 combinations only. That gives up to 10 million combinations. If you use base 62, we can get 62 to the power of 7. That is about 3.5 trillion combinations of unique ID over here, which we can use it for a shortened URL. So look at the difference, 10 million versus 3.5 trillion for the same length of unique ID, that is 7 characters, right? I think this is 6. Let's see, it's something else, okay? For the same length of unique ID, if we use base 10, we get only 10 million combination. If you use base 62, we get 3.5 trillion combination. Even if we use, if we consume about 1,000 unique IDs per second, we can easily run our system up to 110 years using base 62. Even if we use, if we consume about 1,000 unique IDs per second, we can easily run our system up to 110 years using base 62. You might be wondering how to generate base 62 number using some random number. And here is the code. It is very simple to understand. I leave you guys to understand this code. Now let's talk about what database to use. We can use RDBMS or we can use NoSQL. RDBMS gives ACID, which is good, but the problem is scaling. You can say that we can use sharding to scale, right? But that increases the complexity when we want to have our application in a distributed manner or horizontally scaled. Because we have about 30 million users per month, there will be a hell lot of writes and reads happening. It is pretty hard to scale the RDBMS. So for that reason, we can go for NoSQL. But the problem there is its eventual consistency. We write something, it takes some time to replicate to a different node. But the good thing is it is highly available and it is a lot easy to scale. All we need to do is keep adding the nodes when we want to expand our storage or database. Now that we learned different techniques to generate short URL, that means to generate 7-character unique ID using base 64 or MD5 hash techniques. Now let's see how to insert the long URL to short URL mapping into the DB. You might be thinking that is so simple. You have a long URL, you have a short URL, you create a DB which has column called long URL, which also has column called short URL. You index the short URL and insert this mapping into the DB. But it's not that simple because there are other problems before you insert into the DB. Say, for example, you have got a long URL. Now, to convert this long URL to short URL, what you do is, say, for example, you chose base 62 techniques to convert the long URL to short URL. What happens is, you try to get a random number. Using this random number, pass this number to base 62 library, and that will convert into 7-character unique ID. Using this unique ID, you can generate a short URL. That is, all you need to do is take this unique ID and place it here next to the domain of the short URL. Now, you have got a long URL, and you have a mapping of a short URL here. Now, what you need to do is, you have to insert this mapping of long URL to short URL into the DB. Okay? Now, what happens? If you insert directly, it won't work. Why? Because since we are generating the random number, the possibilities are we could have already got the same random number. Because of same random number, base 62 would have given the same short ID, right? So what we need to do is we have to ensure that this short URL is not used for some other long URL. What you need to do for that is you need to check in the DB, check that this short URL already present in the DB or not. What you need to do is check if that URL is present. If so, what you need to do is you need to get a new random number and generate a new short URL for the given URL. If not, you can directly write the mapping into the DB. But this technique works only for the simple system where you have one app server, where there are no parallel process trying to insert data into the DB. When you say, for example, when you have multiple app servers, like you have app 1, app 2, app server 3, all the three will be taking care of the traffic to convert long URL to short URL, right? What if at some particular point of the time, both app URL got same random number, for example, 11, for different long URL, say long URL A, long URL B. For these two long URLs, what if these two apps generated the same random number, which resulted into generating a same 7-character short URL, right? This URL, right? Say, for example, you got a URL which is same as the URL here because of same random number. But the problem is they both have a different long URL. Now, what this app server does is, both the app server, what it does is, they go to the DB, check if this short URL exists in the DB or not. The DB will reply that it doesn't exist. What these two app servers think is, since the short URL doesn't exist, I can insert it directly. What these two servers
Oh
does
man, this is
they
so
both insert
boring.
mapping into the table. Say
I'm
long
almost,
URL A
I'm almost sleeping.
and short URL, say I'll take short URL as X.
Is there something interesting?
Straightforward problem. You have these two functional requirements. Given a long URL, get a short URL. So when somebody wants to shorten a URL,
This is so boring. So boring. Let's do something else. I don't have any energy to delete code. I'm just too tired. Let's do one thing. Like I haven't done anything the whole day after the interview, but I'm gonna take a break. I'll refresh. I'm so sleepy. I slept enough for the for the day, but I'm just sleepy. I'm gonna stop the stream right now, and I'll be back in like an hour. I'm sorry.